The second section in Unit 10 is actually section 9.2 in the book. We're going to be using the Pythagorean theorem. The Pythagorean theorem states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. So let's start by looking at our right triangle. So I have my right angle in the corner. Where are the legs? Remember that the legs are the ones that meet to form your right angle. So segment AC is a leg and segment BC is a leg. The hypotenuse is the side opposite that right angle, opposite your 90 degrees. Remember that when we discuss opposite, we mean across from, and adjacent is next to. So the side opposite the 90-degree angle is segment AB. This is our hypotenuse. We've labeled the sides C for the hypotenuse. We always label the longest side C so that we can use our Pythagorean theorem. A and B can be either leg. So while I have the leg that's on the bottom labeled A and the one going up the side is B, either leg that meets to form the right angle could be labeled A or B. So looking at our Pythagorean theorem, it's the hypotenuse squared is equal to the sum of the legs squared, or C squared equals A squared plus B squared. Now, while you're probably used to seeing this written, A squared plus B squared equals C squared, I would like for you to form a habit of putting the C squared first, because we're going to use that and put the C squared first to determine what kind of triangles we have. Let's look at some examples using our Pythagorean theorem. Example number 1, A is 3, B is 4, and we're trying to find C. So we're going to plug in to A squared plus B squared equals C squared. A is 3, B is 4, and C is what I'm looking for. And I'm going to leave it C instead of plugging in an X so I know which side I'm finding when I solve. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. To undo a squared, we use our square root, and if I do the square root of the left, or the right, excuse me, I must do the square root of the left, and C is 5. Again, because we're finding lengths of sides, we only want the principal or the positive square root of 25, so we're not going to use our plus or minus, we're just going to use the positive 5. I'd like to talk for a moment about the answer to this problem. Our answer that we got is 3, 4, 5. 3, 4, 5 is what's called a Pythagorean triple. These are 3 positive whole numbers that satisfy the Pythagorean theorem. And you can look up, if you Google Pythagorean triple, there are tables of triples. So we'd like to kind of start recognizing these to help you do some things with some problems we'll be doing in Unit 11. If 3, 4, 5 is a Pythagorean triple, which it is, multiples of this triple also satisfy the Pythagorean theorem. So if I did 6, 8, because 3 times 2 is 6 and 4 times 2 is 8, the third answer would be 10. These satisfy the Pythagorean theorem because 6 squared, 36, plus 8 squared, 64, equals 10 squared, 100. There are many, many Pythagorean triples, and we'll be discussing these as we work through these sections. Number 2, B is 12, C is 13, A is missing. Again, we're plugging in to A squared plus B squared. And I'm going to put my C squared first. We want to try to make this a habit to put C squared first. So 13 squared equals A squared plus 12 squared. 13 squared is 169. 12 squared, remember you're doing 12 times 12 is 144. To solve, we're going to subtract 144. And we find that A squared is 25. To undo a squared, we do the square root of both sides. Again, just our positive or principal square root, so A is 5. 5, 12, 13 is also a Pythagorean triple, 3 whole numbers that satisfy the Pythagorean theorem. Go ahead and try the next example. Pause your video, try this one. We'll be plugging in to C squared equals A squared plus B squared. C is what we're trying to find. A is 6, B is 4. So C squared equals 6 squared, 6 times 6 is 36, plus 4 squared, 4 times 4 is 16. And if I add those up, I get 52. Again, to undo a squared, we're going to do the square root of both sides because our squared and our square root cancel. 52 is not a perfect square, so we're going to use our factor tree. 2 and 26. And again, as you're doing your factor tree, if a number breaks apart, it's often helpful to mark that number out so you don't try to go back and use it. So we have a pair of 2's and a lonely 13. One from the pair comes out. Lonely numbers stay in. Example 4, plugging in to c squared equals a squared plus b squared. A is 5, c is 7, and b is what we're trying to find. Then we're going to solve 7 squared. 7 times 7 is 49. 5 squared. 5 times 5 is 25. We're going to get b squared by itself by subtracting the 25. So b squared equals 24. To undo a squared, we'll do the square root of both sides. And b is going to equal what we get when we do the square root of 24. Since 24 is not a perfect square, I'm going to do my factor tree. Again, looking for perfect squares when you start the factor tree will make the process easier. I know that 4 goes into 24, and that's a perfect square. 4 is a pair of 2's. Again, mark out those numbers so you don't try to use them. 6 is 3 and 2. So I have a pair of 2's, a lonely 3, and a lonely 2. One from my pair comes out. The lonely numbers multiply back up, and we get 2 rad 6. Number 6, plugging into c squared equals a squared plus b squared. For this problem, a is rad 3, so we have rad 3 squared. B is rad 7, so rad 7 squared, and c is what we're trying to find. We've discussed that squaring a radical causes your radical and your squared symbol to cancel. These are opposites. So rad 3 squared is 3. Rad 7 squared is 7. So c squared equals 10. To undo the squared, we're going to do the square root of both sides. And if I try to do a factor tree with 10, I get 2 lonely prime numbers. So this one stays, square root of 10. Don't forget to leave your radical over your answer for this problem where it gets stuck and there are no pairs. Let's try another one. Number 6, plugging into c squared equals a squared plus b squared. A is 2 rad 3. B is 2. And c is what I'm looking to find. Okay, again, in our radical unit, we talked about squaring things like this that are multiplied. And really what you're doing is you're squaring each part or you're multiplying it by itself. So I'm just going to go off to the side and write it out. I don't need FOIL, anything like that. This does not have any addition or subtraction. We multiply regular numbers by regular numbers. 2 times 2 is 4. Square roots by square roots. And we talked about rad 3 times rad 3 is rad 9. Square root of 9 is 3. The number underneath just comes out, and we get 12. So we have 12 plus 2 squared is 4. Therefore, c squared is 16. To undo the squared, we do the square root of both sides, and c is 4. These last two problems are not Pythagorean triples because they're not whole numbers. They're answers that have radicals in them. Let's look at a couple special pictures. Looking at our square, how can we create a right triangle? We're going to draw the diagonal in. And where would the hypotenuse be? The hypotenuse would be the diagonal that we drew in. Now we have a right triangle. So if I had the sides of the square, and remember the sides are the same, we could use the Pythagorean theorem to find the length of the diagonal. Next special picture is our rectangle. How do we create a right triangle? Again, we're going to draw on the diagonal. And then where is the hypotenuse? Also, once again, our hypotenuse is our diagonal we drew in. So if we're given some side lengths, we can use c squared equals a squared plus b squared. And where the sides are your legs, your a and b, the diagonal is your hypotenuse. Last picture. We'll do this a lot with equilateral triangles where it's a 60, 60, 60. All three angles are the same. To create the right triangle for this one, we're actually going to draw on the altitude, which is the height, from a vertex to the opposite side at 90 degrees. What this does is it creates two right triangles. The hypotenuse is the side opposite the 90-degree angle, so here's a hypotenuse and here's a hypotenuse. Therefore, I could do a leg squared plus leg squared equals this slanted side squared. We'll be working on handout 10B, which is review over the first section, and handout 10C, we're going to start with number 1 through 26 only.